Hello everyone, so we will be now looking at some examples on polygons and quadrilaterals. So take a look at the first one. So here you have this is a CAD question again. So you have a square ABCD, PBC is an equilateral triangle, and then you have dropped a perpendicular, you have to find DPQ, so that angle that's marked. So now if this is a square, then clearly these are all 90 degrees and this is an equilateral triangle. So that means this is 60 and this is 30. Now the important point to observe is, you look at the sides PC is equal to BC because it's a part of an equilateral triangle, but DC is also equal to BC because they're part of a square. From here we can conclude that PC must be equal to DC. So if this angle is 30, then this angle plus this angle would be 180 minus 30 is 150. Since this is isosceles, each angle becomes 75. So if this is 75 and this is 90, then the required angle here is 180 minus 90 minus 75, so that's 15 degree. So that is our answer to the first one. Let's take a look at the second one. So here they is saying PQ and RS are parallel. You have to find out the length x. The sides have been given in terms of x. Now as you see, this is parallel. So this triangle and this triangle are similar. This angle is equal to this angle is equal to this, and these two angles are anyways equal, vertically opposite. So x plus 5 corresponds to 1. So side ratio I am writing x plus 5 by 1 is equal to 13x minus 31 divided by x minus 2. So just cross multiply rather. So we have x squared plus 5x minus 2x minus 10 equals 13x minus 31. So x squared minus 10x minus 21 is 0. So this is plus 21 rather. This is x minus 7 times x minus 3. So x is 3 or 7. So if I put x as 3, then this becomes 1, this is 8 and this is 8. So 8, 8, 1, 1. That's possible. If I put 7, 91 minus 31, so that's 60. This is 5. So 1, 5, 60 and 12. So that is also okay. So the values of x are 3 or 7. Let's take a look at this. It's a polygon question. ABCD if F is a regular hexagon. Let's draw that. So you have to find out area of ACE. So that is this to the whole of ABCDEF. So now if you start finding out the lengths of sides and stuff and angles and areas, it's going to be difficult. For hexagons and stuff, it is very easier to actually split this into smaller units and then try to figure it out. A simple way of doing that is pick the center and join. Okay, and join again. First let me remove these 3 lines, okay, and join again. So now see what we have. Interior angle of a regular hexagon is 180 times 6 minus 2 divided by 6. So that will be 4 times 30, 120. And when you draw centers, they will all be split equally 60, 60, 60 everywhere. So you are going to get lots of equilateral triangles. So if I were to now join ACE back, you observe this length. So this is, let's say, length L, this is also L, this will also become L, this is also L, because these are all parts of those equilateral triangles, right? They are all L, this is also L. So here we have ABC and let's call this O. AOC are congruent because AC is common. This angle is 120, this angle is 120. AOCO are equal, AB, BC are equal. So basically we have this triangle equal to this triangle. Again this triangle equal to this triangle. And finally this triangle equal to this triangle. So triangle ACE is exactly half of ABCD EF without having done any calculation, just by splitting the diagram down. So the answer is the second option. I hope these were clear. Thanks for watching.